Hello, yeah. In this video, I will show you how to perform causal mediation analysis using R, actually the package mediation. So the causal mediation analysis is more advanced than the traditional Sobel's test. The mediation package implements state-of-the-art causal mediation analysis. It uses a counterfactual framework, estimates ACME, average causal mediation effect, which is the indirect effect, and ADE, average direct effect, using Pearl's causal mediation formula under sequential ignorability. And it uses quasi-Bayesian bootstrap to do the estimates, also generate non-parametric percentile confidence intervals. You can use like over 1,000 simulations. Robust to non-normality and skewness. And it has good model flexibility, supports LM for linear regression, GLM for generalized linear models, GAM, generalized additive models, survival for survival models, and multi-level models for, say, longitudinal data, okay, for mediator and outcomes. And also you can perform sensitivity analysis, which use the medsens tests robustness to unmeasured mediator outcome confounders. And also it can handle multiple mediators, okay. So very powerful, useful package. Let me do a demonstration now. Let me load in the mediation package, the survival package, and the LME4 package. Random seed, generate a covariate X, the treatment X, which is binary, and then covariate 1 and mediator 1, which is continuous, mediator 2 is a binary. Okay. So first, let me do the linear model data set. Just create the Y dependent and put everything else into a data frame. Then the first step, if we want to do M1 mediation, the first step to fit a linear model, M1 regress against X plus C1. And then we do a outfit 1, which is a regression model of the dependent of Y, regress X, M1, M2, and C1. And then we use the function mediate, which is putting medfit 1 and outfit 1, treat equal to X, mediator equal to M1, bootstrap equal to 2, simulation equal to 500. Okay, and let's see, the continuous ACME is 0.709. And if we want to, look into more details about output, you can see it generate this table, non-parametric bootstrap confidence intervals. With the percentile method, you can see the ACME, the ADE, the total effect, and the proportion mediated. Okay, and the p-value here, the 2.2e to the negative 16, is the smallest value R can store. Okay, so this is a highly significant mediation effect. Okay. All right, and we want to do M2 mediation. Remember, M2 is a binary, so we have to fit this mediator model. So M2 we use a logistic regression model, and then we use the out2 linear model. We still use the previous outfit 1 model, use the mediator function, and then do the non-parametric non-parametric bootstrap. And now this time the ACME is very small, 0.08. And if we print out the whole table, you can see now ACME is not significant. P is 0.168. Okay, and it's only the proportion of mediated effects is only like 3%. Okay, and you can do a sensitivity analysis using the medsens function. Just put in this mediator object and then say effectively indirect. And then you can print out the result. So here you can see the rule, and you can see the confidence intervals and the R squares. So what you want to take a look is really the value of the rho, if rho is the correlation between unmeasured mediator outcome confounders. So you want it to be large. Then you confirm there is a confounder. Okay, so if rho is less than 0.1, it's negligible. Confounding between 0.2 and 0.3 is a moderate, usually still safe. 0.4, 0.5 is strong, those we make it questionable. And then 0.6 or plus, extremely strong, so almost impossible to deny. Okay. All right, now we can go to the logistic regression one. So I have to regenerate the Y, so it's binary, and then I need to fit the out GLM now using mediate. And now as you can notice step, I just put in the logistic regression total model, the out model in there, and then let's just let it just calculate. Now the ACME is 0.85, also not big, but however, you can see it actually stratified on the X1, the treatment versus control, and you can see, and also they also have combined the averaged one. So you can see, although they're not big, but you know, they're all significant. All right. Now let's go to survival model. And for this one, we need to regenerate the data with the lambda, the event time, the sensor time, and then put everything together into a survival data set. And then because I ran into a lot of error messages, complaining about the type of data not being numeric, so I'm going to do this extra step to force them to be all numeric. And then we can fit the mediator model. And then now I give you the warning to do the survival model. Do not use the Cox regression model, the coxph. Okay, I ran into so many errors. I could not even figure them out, cannot debug it, because it seems likely when you do mediation analysis, it's going to refit many Cox models, and then there's some issues communicating between the packages. So it's just a lot of hassle. It always complain about type of data not being numeric. It's about the non-conformity. Maybe the matrices are of a different dimension. I don't know. So eventually I gave up on Cox model, and then I used the survreg for parametric regression. Okay, so we can regress that on the retrieval time on all the variables, and we can specify a Webel distribution, and then we can do the mediation analysis. Okay. And now you can see a similar outputs, and also now this time the little bit higher proportion of mediated average is the 27%, but they're all significant. All right. And then let's go to the multi-level one. Okay. And again, I have to create the data set because it's a longitudinal data. So once I create it, I just run linear mix model for the mediator one. And then I run the linear mix model for the dependent variable. And now I'm going to use mediate function to met a fit lmer and out mer treated with x model mediated with m1. Now here, boot cannot be true. Otherwise, it gives you a error message. So you use the false, and then you can cat. So this one's 0.8. So it's a pretty big mediation estimate. If you want to really see the whole thing, you can summarize this model fit and give you 0.628. So explain about 14%. And we can do some cosmetic work to put everything together. So this is the model, that's MSE, and yeah, all the estimated effects are here. Of course, they're based on different data set. Okay. All right. I hope you liked this video because I think the causal mediation analysis is kind of pretty new and advanced. I'm glad they have developed this R package called mediation, which has very, very good implementation for this cutting edge mediation analysis method. Thanks for watching.